The easiest way to set a breakpoint is by clicking to the left of the line of executable code where you want to set the breakpoint, in the vertical space to the left of the editor, which is called the gutter. You can also insert a breakpoint by highlighting the line of code, right-clicking the mouse, pointing to breakpoint, and then clicking Insert Breakpoint. You can also use the menus. Click on the line of code where you want to break, and then select Debug Toggle Breakpoint, or press F9. So a lot of different ways. Very frequently you'll find in Visual Studio there's numerous ways to perform the same action, just depending on whether you want to use the mouse and menus or a keyboard or however. After you set the breakpoint, you can then start debugging by selecting Debug, Start Debugging, or pressing the F5 key. This will run the program until it reaches a breakpoint, and then it pauses execution. Once it pauses, you can step through the code. Stepping through code provides another useful technique for debugging. Once you've stopped execution, the debug menu provides 3 commands for stepping through code. The first is Step Into. Stepping into code lets you move into a block of code, which could be a constructor, property, indexer, or various other kinds of objects, but often it'll be a method. Whenever your debugging position is over a method, you can select Debug Step Into or press F11 to move inside the method. And there's also a toolbar button that I'll show you. And then you can also step over. If you don't want to debug a method, you can use Step Over, which lets you move to the next statement at the current level of the code rather than stepping into the code of that method that's being called. And you can do that by selecting Debug Step Over or pressing F10. And then the third option is Step Out. Sometimes you'll be inside of a method and will have seen everything you need. Instead of spending time stepping through the remaining code of the method, could be hundreds or thousands of lines, particularly if you're deeply nested, you can do a step out, returning to the calling code, and then execution pauses there. And then to do a step out, you select Debug Step Out or press Shift F11. Step Into and Step Over differ in only one respect: the way they handle calls to other methods. Both commands instruct the debugger to execute the next line of code. If the line contains a call to another method, Step Into executes only the call and then halts at the first line of code inside that called method. Step Over executes the entire method, whatever code is in the method, other calls it makes, and whatever, and then stops execution at the next line after the method returns. So you want to use Step Into if you want to look inside the method call, and use Step Over if you want to avoid stepping into the called method. So Step Over can be handy if you know that the method that's being called is not the source of the error. You've thoroughly debugged it, thoroughly tested it. You don't need to look at that code again. Just use Step Over. Otherwise, you can step into it and step through the lines of code. All right. In addition, you can use the Locals window to examine, and if necessary to change, all the currently available local variables. You can only view the Locals window while in break mode, that is, after you've hit a breakpoint and you're stepping through the code. All right, let's take a look at how you can use breakpoints when you're working with your application code. So in this case, I want to set a breakpoint on this line of code that prompts the user to enter their age. So I'll come over here to the gutter. This is the easiest way to do it, and just click to the left of that statement. So notice that this is now highlighted in red. If I move away from that line, see it's all in red. Okay, it's just selecting that particular age variable, so that's why that turned blue. And so now I have a breakpoint that'll be hit whenever execution comes to that line of code. All right, notice that I have a couple options here. I can disable the breakpoint, so I'll go ahead and click on that. Notice that I have the faint outline of a red circle there. And when a breakpoint is disabled, it's not going to stop execution. But this is handy. If I'm really debugging a gnarly problem, I'm not sure where it occurs yet. There's 5 different places where I have breakpoints because I think they might be in different locations, but I want to run straight to one particular location. I can disable various breakpoints, and then it won't stop here. But then I can easily come back and re-enable that. Okay, I'm going to come back over here and re-enable that. And then I can also, there's various settings that I can use in order to work with that breakpoint. I'll talk more about those later. Okay, so now I have a breakpoint on that line of code. So I'm going to press F5 to execute the application. And notice that the window appeared briefly, and then I'm back in Visual Studio, and execution has paused on this line. The line is in yellow because that's the current location of the execution. Okay, by default, in many cases, Visual Studio, when you stop, when you hit a breakpoint, will also open a diagnostics window that by default appears right here. This has information about events, process memory, CPU utilization, and more. This is an advanced debugging and diagnostic tool that's useful, but definitely outside the scope of what I'm talking about here. Way propeller head kind of debugging sort of information is in that window. So I've actually disabled it here within Visual Studio. Okay, notice that I have some additional windows down here. I have autos, I have locals, and I have watch. Watch window I'm not going to use here, but I can watch the value of different variables. And I can actually break when they hit different values. I'm interested here in the locals window. Now, if this doesn't happen to be open, you can come in here to debug and other windows someplace, windows right at the top, and it appears right here. So this is not on the view menu, which is where many windows are, but as you can see, there's a lot of different debugging windows that you can use as well. But generally by default, if you haven't changed the configuration of Visual Studio, the locals window will appear as well as the autos window. And this displays all of the variables that are currently in scope, that are available and in memory. I have these arguments. I'm not using those arguments, but you can pass values to when you execute this program from the command prompt that you can get in as a string of arrays. I'm not using that, not relevant here. But here's my age value, and I can see that it's currently set to 0, which makes sense because I've displayed that value. I haven't executed this line of code yet, and so I've not yet prompted the user for a value. When I declare an integer value and don't assign it a different value, it gets the value 0. So that's why it appears as 0 there. And I can also see that the type is an integer. Okay, back over here in the autos window, this shows you variables on the current and previous lines, which might be useful to limit the amount of data that you see at one time. So if you're just dealing with a small subsection of code, then you want to use the autos window. But if you want to look at all of the variables that are in scope at the moment, use the locals window. Okay, and when you're in debug mode and execution is stopped, Visual Studio also displays a debug toolbar. And these have the step into, the step over, and the step out toolbar buttons that I mentioned. Okay, so I'm going to go ahead and step into this code. So now it's prompting for the age. So I'm going to enter 28 and enter. And so the read line method has executed. It's been converted to an integer value, and you can see that I have an age value of 28. Now, the locals window has a little bit more information here because it will display information from, or the return values for methods that I've just called. This is relatively new in Visual Studio. So I can see that the readLine method, this embedded method here, returned a string of 28 because when working with the console, I'm dealing with string values. And then I used the toInt32 method to convert it to an integer, and now it's 28 as an integer. So you can see string and integer. Okay, so those are real handy additions. They do add a lot of information to the locals window, but they can be very valuable information. Because I may do some other processing here, and in fact maybe toInt32 is returning an incorrect value. If I didn't have this, I might see that the readLine method was returning a value that I wasn't expecting, but I wouldn't see that if I didn't have the return value for that method. All I would know is 2 and 32 is doing something wrong, but I don't know if it's because I'm passing a bad value or something internally is going wrong with it. Okay, and then you can look over in the autos window and you can see that you get those two values as well for those two methods. Okay, so from there I can continue to step into. So as you can see that it's stepping into this. My value is 28. I can see that that is outside of that range there. And so, okay, yeah, that's correct. That's where I should be. And I can continue to step into. It'll execute that line, that line, that line, and then execution completes, and I come back to the window. Okay, I'll go ahead and hit enter, and that ends execution. Oh, no, actually, I have one last statement there, because it considers, for the purpose of debugging, it considers brackets as statements, because I may want to look at the different values as I'm leaving this method, because once this method goes away, then I'm no longer going to have access to those variables. So I'll go ahead and step into there, and notice that execution now ends because I'm outside of that method. Okay, you can do more with breakpoints. If I come over here and I right-click on that, I can delete the breakpoint, I can disable it, but I can also set conditions. I can also set various actions. Selecting either of those actually opens the same window. And here I can define a conditional expression. And in this case, if I set a condition, then this breakpoint is only going to stop execution if that condition is met. So for example, I could use age value is less than or equal to 21, or greater than or equal to 58, or whatever I might want to set there. So you have a lot of flexibility in what happens. And then you can also set various actions that occur. And you can do things like logging a message and continue execution, and there's a lot of different options there. Okay, so I'm just going to close that window without doing anything, because I just want to unconditionally break on that breakpoint. Now another option you have is you can actually go in here to Windows and Breakpoints and open up a window that displays all of the breakpoints. And this is where disabling breakpoints really comes in handy. So I can deselect that right there, and so now that's a disabled breakpoint. So it makes it really easy to disable a whole bunch of breakpoints that I may have set, or enable them selectively. I don't have to go to the location in code where they are, because they could be in different code files. They could be thousands of lines of code separated from each other. So I can disable and enable them here from just within this single window. And so there's a lot of things that you can do from this window. You can create new breakpoints, you can specify different columns to view, and filter the list using a search function. You can also organize the breakpoints. You can right-click on a breakpoint and select Edit Labels, and then you can search on labels and perform actions and so forth. A lot of different things you can do within this. But most of the time, you're going to set a breakpoint, it's going to stop, you're going to examine the locals window, perform other tests, do whatever it is you need to do to figure out what the problem is with your code, or benchmark the code, or examine what's going on so you can step through and make sure that the logic of this complex logic that you defined in code is doing the right sorts of things. A lot of things you can do with breakpoints. Okay. So that's the breakpoint window. Let me go ahead and I'll go ahead and close that. And then there's a few other things that you can do that give you a lot of flexibility when moving around within the debugger. So I'm going to start this application again. It'll once again stop at that breakpoint. And then I can say scroll down here and right click on a line, and I can do things like run to the cursor. So then I'm going to execute the application, until I get to the cursor. So I did that on not a teenager, so I'll put in 45. Oh, I actually did it on the wrong line. So let me run it again. So I'll come here, not a teenager, run to the cursor. So now it's going to run. I'll put in 56, and now it stops at that statement where I indicated where I wanted to stop execution next. Another thing I can do is, okay, I'm currently at this line here. I don't want to execute that line. Instead, what I want to do is I can right-click on this and select Set Next Statement. So now that becomes the next statement that's going to be executed, and I've jumped from that one. That one didn't get executed, so it's different from Run to Cursor. It doesn't execute this statement, and comes here, and that's going to be the next statement that is executed. This is particularly handy with loops. If I'm running a loop over and over and over again, I can move to different parts of the loop, move to before the loop started, move to after the loop terminates, and move around the code. So very quickly I can move to where the next statement I want to execute. But in this case, maybe this is the next statement that I'm going to execute. I want to run this whole thing again without running the entire application again. Maybe there's a lot of setup code. It takes 5 minutes for the application to get to where I really want to examine. So instead what I'll do is I'll come back up here, right-click on that, and set that as the next statement. And now I can execute all of these lines of code again. You just need to be aware there may be side effects of different variables set to different values that you're not expecting because you're just randomly jumping around the code. So you do have to be careful with that. So those two statements are alternatives to setting breakpoints. You can control where the application is going to go from wherever it is when you stopped execution at a breakpoint.